Hello, good morning, everyone. Welcome to the fourth lecture on homework portal. Okay, so yesterday I had posted a few questions, 5 questions, and this video is about the solutions for these questions. Now let us go through it one by one. So as you see here, you have a sphere which is being fitted inside a cube, and he's asking you to find out what is the percentage uncertainty of the volume of the sphere. Then the length of the cube is given to be 10 plus or minus 0.2 centimeter. So what does it tell you? It tells me that this value is given to you. Now what is the radius then? The radius of it is seen to be 0.5 centimeter plus or minus 0.2 centimeter. Not 0.5, I'm sorry. This is 5 centimeter plus or minus 0.2 centimeter, right? See, when I halve this distance, I'm not going to halve this uncertainty because it's along the same linear line. So I'm not going to halve this. It will remain the same. So as a result of this, now let us find out. We know that this volume of the sphere is given by 4 by 3 pi r cube. Volume of the cube is given by a cube. So therefore, when I do delta v by v for a sphere, this should just be equal to 3 times delta r by r, while delta v by v for the cube will now be equal to 3 times delta a divided by e, right? Where a is equal to the edge of the cube. So when I divide one by the other, I get this 3 and 3 gets cancelled, and thus I get delta r by r divided by delta a divided by a. Delta a, oh my god. Just a moment. There's something wrong with my pen. Okay, delta A by A. Oh, I rubbed this off, right? This should be delta 3 times delta R by R. And this should be 3 times delta A by A. And when I do this, I get this as, for the sphere by cube, which should be delta R by R divided by delta A by A. This should be the answer. Now, what is delta R by R? Delta R by R is nothing but 0.2 divided by R value. What is R value? 5 divided by, what is this value? 0.2 divided by 10. Okay, when I do this calculation, what do I get? I get 0.2 by 5 into 10 divided by 0.2. This goes away. 5 ones are, 5 twos are. Thus the answer is 2. Thus the answer is 2 over here. Right? So the answer here is C. Okay? So this is how you need to answer it. The misconception, which many of them do it here, is that they consider delta R and delta A to be the same. And as a result of it, they make a mistake over here. Okay, now let us move on to the next one. Now it says an aircraft is moving horizontally. A parachutist leaves the aircraft. Few seconds later, opens her parachute. Which graph shows the variation of the vertical speed v with time t for the parachute for time she leaves the aircraft until just before landing? So it's a VT graph. So initially what's happening here? Okay, the aircraft is moving horizontally. Okay, and parachutist leaves the aircraft. A few seconds later, opens the parachute. Variation of the vertical speed v with time t for the parachutist from the time she leaves the aircraft. The moment she leaves it, then what will happen? She will have some speed, right? Now, what is the speed? She will have some horizontal speed, but here it is about vertical speed. So therefore, horizontal speed is not considered. So the moment she opens her parachute, now what will happen? So the moment she falls, because of gravity, so her vertical speed will increase. See, it is increasing here, it's increasing here, but here it is decreasing. Here it is decreasing. Can that happen? No, it cannot happen. So therefore, C and D are incorrect, right? Now let us look at A and B. Now here you see it is increasing like this. Then the moment she opens it, the parachute is also opened. Then what can happen? It will reach a terminal velocity. You reach a terminal velocity. Okay. And then as she starts gliding down, what should happen? It should not be with the same constant velocity. Its velocity should decrease now. So the velocity will decrease over here. See here it see, okay, it is seen to be the same constant velocity, because if she falls down with this much velocity, that's it. Okay. She will break her arms. So this is incorrect. So A is the right option. Okay, now let me move on to the next one. An object of mass m rests on a horizontal plane. On a horizontal plane. The angle theta that the plane makes with the horizontal is slowly increased from 0. So what do I do? Let me increase this plane. I increase it like this. Okay, I'll write it like this here. So I'll write it like this. Now it is increased with respect to the horizontal. When theta equal to theta naught, the object begins to slide. Object begins to slide at theta naught. What are the coefficient of static friction mu s and the normal reaction n of the plane at theta equal to theta naught? What is the coefficient of static friction? What is static friction? Static friction means the object does not move, right? So therefore, this is my normal force. This is my mg cos theta 0. This is my mg. Then this is my mg sin theta 0. And this would be my frictional force, right? At static friction, what will happen? Frictional force will be equal to mg sin theta 0. Now, what is frictional force? Frictional force nothing but mu times n, which should now be equal to mg sin theta 0. What is n? N, as you see from here, n is equal to mg cos theta 0. So, mu times, just a moment, mu times cos theta 0, I lift an mg, just a moment. mg should now be equal to mg sin theta. This mg and this mg goes away. Thus mu should now be equal to tan theta. Tan theta 0. I miss a 0 here. Okay. So the answer is tan theta 0 here. Now therefore, this and this are incorrect. Now these two are blending. Now at the same time, what is the normal reaction? Normal reaction should be equal to mg cos theta naught. mg cos theta naught. So this is the right answer. Okay. Now let us move on to the next one. A ball with mass m moves horizontally with speed u. The ball hits a vertical wall. The ball hits a vertical wall. Ball hits a vertical wall and gets rebound in the opposite direction with speed less than u. Oh, it moves horizontally. I am sorry. It moves horizontally. It hits it and it gets rebound like this. Okay, so this velocity is v, this velocity is u. Duration of the collision is t. Okay, now what is the magnitude of the average force exerted? Average force and loss of kinetic energy. What is average force? Average force here is nothing but final momentum minus initial momentum divided by time taken. What is the final momentum? If I consider this direction to be positive, then this should be mv minus this direction should be negative, because if this is positive, this should be negative. Minus mu divided by time taken. Divided by time taken. Divided by time taken. I'm sorry, I'm not able to write it. Okay, anyway. So mv minus mu minus, this should now be equal to mv plus mu divided by t. Let me write it down here. That'll be better, I think. This should now be divided by, oh my God, just a moment. Let me take up the corresponding pen. Use this one. This will be t, which should now be equal to m into minus, the minus becomes plus. So m into u plus v divided by t. See, m into u plus v divided by t is in both the conditions. So therefore, this is incorrect. This is also incorrect. Now you need to find out what is the loss of kinetic energy. The final kinetic energy will be equal to half mv square. Initial kinetic energy would be half mv square. So loss of kinetic energy would be this one. And so this is also incorrect. mu square by 2 minus mv square by 2. So therefore, this is the right answer. Next. A train on a straight horizontal track moves from rest at constant acceleration. Constant A. I'm just going to write it using this. Maybe tomorrow I'll get a new pad. There's something wrong with the pad, or maybe the device drivers are not working. The horizontal force on the train and the engine force and the resistive force which increases the speed. The horizontal force on the train or the engine force and the resistive force which increases the speed. Okay. Which graph represents a variation with the time t of the power P developed by the engine? So how do we do this? So what do we need? The power. How do I write the power? Power is equal to F into V. What is F over here? The net force acting on the engine. What is being asked? Graph with power being developed by the engine. F over here. And it also says resistive force which increases its speed. Resistance force which increases the speed, which means what? This is now proportional to K times V. And this multiplied by V. So this should now be equal to K times V square. V square. Thus, which is the right option? D is the right option. Okay. So with this, we come to an end for the homework problems, solution to the homework problems. We'll see this tomorrow once again. A new set of problems will be uploaded. Do solve these problems as it becomes important for you in understanding the subject. Thank you. Thank you very much. Do share and subscribe to my channel. Oh my God, where is it? I'm not able to see this. Okay. Do share and subscribe to my channel for more updates. So it's better that you answer it on the comment box, and it will really be helpful to me to understand what kind of problems do you face. Thank you.